And we're recording. This is the Kubernetes SIG Network meeting for Thursday, November 16th, 2017. We have a relatively small agenda today, so let's see how I can get through that. Why don't we start actually with Ed, who wants to talk about VPP, and I'll save the test review in case some of the Google guys show up slightly later in the meeting.
Yep. So I'm completely fine with that as long as you'll cut me off to make sure I don't take too much of your time.
Sure.
So I've got some slides because visuals tend to help a lot in understanding some of what's going on with VPP. But we can sort of jump around them depending on what folks' interests are with them, because there are lots of interesting things that can be explained here. And I've sort of pushed to the back the how it works magic. Although that's fascinating, it may not be the thing that fascinates you guys.
Are there many people on the call familiar with VPP? Sounds like maybe not.
Cool. All right, so I'll sort of start from the top. And as I said, please ask questions as we go, because that will often lead to interesting conversations and give me a better idea of what aspects you guys are interested in. The whole point here is just to provide some information for you guys. So to understand fully the context, let's sort of start with what FIDO is really quickly. FD.io, typically pronounced FIDO because it's cutesy. It's an open source project of the Linux Foundation. Just like
Hey Ed. Mm-hmm. Sorry, this is Cliff. I think you're not sharing the first slide.
Hang on.
I can see the whole view of it.
Let me stop sharing and start sharing again and see if that helps.
Just so I have a sense of timing, how long do you think you need to go through the slides?
Quite honestly, I can cut it down as short as 20 minutes, and I can do it for as long as 90, which I know is not what
Yeah, let's try to keep it to 20 for now, and we'll see where the discussion goes.
Cool. So basically, FIDO is an open source project similar to CNCF at the Linux Foundation. The point of which is basically to produce a very high throughput, low latency, feature-rich data plane that runs across multiple hardware architectures and runs equally well on bare metal, in VMs, and in containers. It helps a little bit to understand sort of the scope of FIDO because it helps you see where it fits with other things going on in the network space. So we'll often talk about 3 layers. Network I/O, which is how do I get a packet from a NIC or a VNIC to a thread on a core? So DPDK, for example, does network I/O very well. It produces really good drivers that'll haul things into user space for us. And we actually use DPDK for that for physical NICs where appropriate. Next up is packet processing. You can think of this as sort of routing and switching, but it ends up being quite a bit richer than that in modern networking. So classify, transform, prioritize, forward, or terminate traffic. And then something needs to manage it, and we're very flexible about what that something is. And we actually have probably, I think, half a dozen different data plane management agents for different purposes that are floating around right now, depending on what kind of thing you're wanting to do. And one of them, as you'll see a little bit later, is actually just an agent that plugs into Kubernetes so that we provide what Kubernetes expects in terms of networking. Really quickly, where we fit in the overall stack, you've got things like Kubernetes at the orchestration layer. FIDO is providing this data plane services layer, basically touching the packets and moving them. So think of it as what comes out of the pod and goes into networking. There's a broad set of membership, various service providers, network vendors. There's a lot of interest from various hardware vendors who sell chips, mostly because FIDO provides an extremely flexible method for integrating with different kinds of hardware acceleration. There was a question on the chat about a link to the deck. I'm happy to drop the deck any place that you guys find convenient. And again, the contribution comes from a broad array of folks as well. So it's a pretty pluralistic community. From a code activity point of view, this sort of shows from when FIDO was open sourced in 2016. cumulatively commits. So Fido's currently, from the direction of commits, the most active project that I'm aware of in data plane, sort of in the data plane space. Many more commits than both OBS and DPDK. And let me try and see if the slideshow kills my share again. And yeah, it does kill my share. So there will not be animation. Apologies, because Zoom is not being cooperative today.
We'll have to use our imaginations.
Yeah. Hang on. Let me get the share going again. So the sort of the core technology at Fido is something called vector packet processing. It's one of the many projects that we have at Fido. And it's essentially an optimized software network platform. It gives you pure user space networking at extremely high performance, and I'll show you in just a second how high. Pure Linux user space. So this is very nice as things move more and more towards cloud native, because you can actually treat and manage your networking entirely as a microservice, just like everything else. It runs on, as I mentioned before, a variety of hardware CPUs, and it uses a bunch of really sophisticated tricks to squeeze the most performance out of them. And the other thing is, as data planes go, it's extremely mature. It's something that's been shipping at volume, both in server and embedded products, since 2004. So it has all the sorts of telemetry, instrumentation, traces, hundreds and hundreds and hundreds of counters that don't impact performance. So you can throw an enormous amount of telemetry off of the system, probably more than you want to. So I had mentioned performance. This is not something I think is directly applicable in the Kubernetes space yet, but it gives you some idea of what I mean by high performance. Fido on modern Skylake processors is currently able to route a terabit of traffic with millions of routes in the routing table on a commodity server without any sort of magical hardware to assist it. And being able to do that, you're literally sweating every fucking CPU cycle. And that is actually on a minority of the cores on the box, so only 24 cores to push up to those numbers. And there's a fascinating thing. We used to, on the previous generation of Intel Xeons, we were getting 0.5 terabit per second. And at the time, the telemetry coming off the system was indicating to us that the limitation was not, we were not CPU bound. We were actually being bound by the number of PCI lanes per socket. And so when the new Skylakes came out with more PCI lanes per socket, with exactly the same binaries, we saw nearly a doubling of performance just from adding the additional PCI lanes. And the telemetry that's coming off the system tends to indicate that we are still being blocked by insufficient PCI lanes to really exploit what we can do with the system. So there's even more performance to be squeezed out as the hardware improves in terms of being able to deliver packets from the NIC to the core. Any questions so far? All right, cool. So I also mentioned feature rich. This slide is a vast minority of the features we offer, but it's the things that people end up typically being interested in. So I mentioned hardware platforms, not only DPDK for interfaces, but AF packet, vhost user, all of them supporting things like multi-queue, reconnect, jumper frame support. We've got language bindings for C, Java, Python, Lua, and actually now Go that are being automatically generated. So everything in the system is fully programmable all the way down in terms of granularity using an extremely high performance programming mechanism. And you've got the language bindings you need to build whatever kind of agent you want to control it. The full suite of tunnels and in-caps, GRE, VXLAN, VXLAN GP. We've got hardware support for IPsec. So if you have accelerating hardware, we'll do the crypto for you in accelerated hardware. I don't think anyone here cares about MPLS, so I'm going to skip that. For routing, we support v4, v6, hierarchical fibs, millions and millions of routes, thousands and thousands of VRFs, multipath, both VCMP and unequal cost. I think I had some questions when I talked to the CNCF network SIG. They were asking how many paths, and I went and inquired, and the response was 64K, which is ludicrous. But that's just kind of how the people who make this kind of software think. generally we support all the sorts of things you'd want for switching, including bridging with programmable bridge table entries, proxy ARP. We do all the sorts of mandatory input checks that should be done by the system. NAT. We've got reflexive ACLs to support things like Kubernetes network policies, and a bunch of features. The in-band IOM features are actually kind of interesting. They allow you to actually get in-band telemetry for your network traffic. So you can actually find out timestamps, not only when you're hitting the things you do control, but where you hit intermediate routers and switches that will timestamp that for you in the network. So, and this is sort of this is not everything. So if there's a feature you don't see here, please ask. We probably have it. Do folks have any questions on the features available in FIDO? You guys are awfully quiet.
Stunned silence.
I can't actually read the slide, and there's a lot to go through. So it would take me a lot of time and better vision to really evaluate that.
Yeah, let me try something. Yeah, I apologize. It is a little bit of an eyesore, and the presentation mode is not working, which is unfortunate, because that would make it much more visible. That should help a little bit.
That helps a lot, yes.
Okay.
But I'll tell you, actually, the big thing I'm struggling with is where this would play in the Kubernetes world. Are we talking about putting up routers or switches as Kubernetes applications, or are we talking about as some kind of a networking plugin for Kubernetes?
Embrace the healing power of and. So the answer is yes, and I get a little bit into that in literally 2 slides, where I start talking about how this would fit in to a Kubernetes context with networking as a microservice. I didn't expect this group to be so interested in, I want to run a container-based virtual network function, like running a router in a container for purposes other than serving Kubernetes. We could certainly talk about that if there is interest, because that is a use case. But I presume
we are getting that as a use case. I mean, some of our other discussions are, about use cases for networking, and we talked about multiple networks. In that context, we catalog use cases, and definitely we're hearing from people who want to use Kubernetes to host their networking stuff.
So I could go on for another hour about that. So we'll not do that on this occasion. But do know that there actually are, one of the key use cases this can be used for is that use case. And then so really quickly, we tend to run rapid release cadences, so about every 3 months. And because it is running purely in user space, it's a simple upgrade path as you pick up the features that are continuing to turn up every 3 months. So this is kind of where I get a little bit more into where this would fit into sort of a Kubernetes context. So what you could think of is, because VPP runs purely in user space, you can now take the vSwitch function that you need to serve Kubernetes when you plug in via CNI, and you can actually make that a microservice of its own. You can run it in its own pod as a daemon set. And you can then service the other pods running on the node. And in this case, VPP is talking via UIO to the NIC, so you're not going through the kernel network stack at all, which is sort of crucial for getting maximum performance. And this gives you things that are pure user space. It tends to be faster and more scalable. And to give you an idea of what we mean by faster at scale, these are some numbers from our 17.10 release. We run ludicrous numbers of performance tests routinely. And so from 17.10, with 10K sort of stateful reflexive ACLs.
By the way, what do you mean by reflexive ACLs?
Stateful. So basically, apologies, I should probably put that in as stateful. Effectively, what it means is that if I've got an ingress ACL and somebody opens an outgoing TCP connection, I make sure they actually get the ability for the response on that TCP connection coming from the other side to come through.
Got it. Thank you.
Totally. Thank you for asking. So with 10K of them, we're seeing about 5.7 million packets per second, and that's the non-drop rate, meaning we lose not a single packet. And that's on a single core, and this tends to scale a tiny bit less than linearly per core. So effectively, you can scale up to ludicrous amounts of traffic with very, very large numbers of ACLs. So as the complexity of network policies grows, and the number of pods per nodes grow, you have a lot of headroom here.
I guess I should also ask, by ACL, you mean rule?
Yep, exactly. Access control list. So that would be a rule that says, this traffic is allowed to talk to, this is the whitelist of things that are allowed to talk to this particular pod.
What my hang up here is list is more than one item. So I'm just trying to make sure I parse this correctly. Is an ACL a set of rules or a single rule?
I will go back and check and make sure. We'll go back and check and find out, but I think in this case we're talking about 10K rule entries in terms of things that have to be checked against. So,
thank you.
But excellent question.
And does that include concepts like IP set or MAC set?
We don't use so we are not using any of the kernel networking stack.
Okay, but I mean, is there something equivalently fast? Can I define an IP set or a MAC set and have it tested in one time?
Yeah. So, and again, the question becomes, how much traffic can you push now through IP tables using IP set, and with how many rules?
I don't have those numbers at my fingertip. I'm just trying to understand what you're telling me.
Yep. So basically, effectively, what I'm telling you is that we use entirely different constructs that are quite a bit faster than what the kernel is using. So the IP set question isn't as relevant. I understand that you're sort of reaching for analogous things.
Well, no, I'm just trying to understand the expressiveness of a single rule. I'm trying to understand the quantity here.
Okay. Yeah. So a single rule would basically say, here is a prefix. Basically prefix in, prefix out, port range in, port range out, that kind of thing. So you would be a prefix oriented if you were dealing with multiple IPs.
Thank you.
Cool. Excellent questions.
I have a couple of questions.
Sure.
One is on the million packets per second, 5.7. Is it a small packets or
yep,
big?
this number is actually running with 64 byte packets on this occasion.
Okay.
So,
and what would be the number with large packets?
One of the things I actually am going back to my performance team for is I don't actually have, for routed interfaces, I don't have 1500 byte or iMix traffic. I do for NAT, but I don't for ACL right now.
All right. Okay. And I think you have a throughput somewhere you listed before, right? I kind of missed that. But I've been joined a bit late. So, but
yeah.
Can you tell me the throughput on one core you said?
So are you asking about the sort of slides a few back where we were talking about terabit level routing?
Right.
Yeah.
Okay. So I'll take a look at slides later to get that answer.
Yep.
The question I have on the ACLs, what would be the setup as in connection per second impact with 10K?
I'm sorry, I didn't hear you.
What would be the connection setup, like a sort of setup time or CPS impact? What would be the CPS with 10K ACLs?
Okay. That I actually don't have numbers for, but that's a really valuable thing. My performance guys actually are looking for new interesting things to measure. And so what you're basically asking is, if I've got 10K ACLs and I'm driving 5.7 million packets per second through, what additional latency do I pick up in the establishment of connections?
Yeah, right. Yeah.
So I will definitely take a note to add that to the list of happy things that we measure. Definitely.
Right. Thank you.
Because that is definitely very interesting. And that actually gets me to another thing. I would love to understand some of the pain points you guys are seeing with performance and scale, because that gives us other interesting things to go test. So
just a quick interruption. We are at the 20-minute mark, so I think we got another 10 or 15 minutes or so, but just as a heads up.
Thank you very much for holding the line on the time. So we're actually close to the end of my slides after here. We talk a few things past here. I think I got maybe 4, maybe 5 more slides. So for NAT with 60K sessions, we're clocking in, and this is iMix traffic, at about 6.2 million packets per second, about 18 gigabits per second on a single core. And that also scales almost linearly with the number of cores. And in this case, it is actually iMix traffic.
I'm sorry, what is iMix?
So when you look at the IETF standards for how you measure traffic, because when you're measuring things like millions of packets per second or throughput, it actually makes a huge difference what packet sizes you're running through. Because if you turn down the packet size, you can crank up the millions of packets per second. And if you turn up the packet size, you can crank up the throughput. So iMix is an algorithm for producing a mixture of different packet sizes in an attempt to mimic what one would realistically see floating through a network.
Thank you.
Cool. Excellent question. Thank you. These were sort of two things I wanted to highlight. We have tons and tons of other performance data, but these two struck me as being things that would probably be of interest to you guys, because as the number of pods per node increases, and as the complexity of things that people specify with the Kubernetes network policy and services API increase, I expect that scale becomes more important. You can tell me if I'm wrong.
No, it definitely does. I mean, at least in some usage scenarios, we're seeing more than 10K services, and so there's a pain point there.
Yeah, no, I mean, and I mean, one other thing I will mention in passing, while we can certainly sort of service services via NAT, we have a lot of other very sophisticated tools that could give you the same behavior you get from services, but with fun things like direct server return. But that's a sort of a future discussion. So pictures help. Communications with pods. So we actually have two ways that you could have pods connecting to the vSwitch with VPP. One is you could just use a vEth pair, as you guys are very comfortable with right now, that loops through the kernel. But that puts the kernel network stack sort of in the middle. The other thing that is an option is we actually do have a complete user space host stack in VPP that can be used to connect to the pods. That host stack is clocking in right now at about 10 million simultaneous connections with 200,000 new connections per second on 2 core. So it scales really, really, really well. It also does cute things like if you happen to have 2 pods on the same server, rather than going down the TCP stack and back up the TCP stack, it will simply connect them with a FIFO so that you're using socket APIs, but you're not having to pay the tax of running through TCP to move bits between 2 pods in the same box. And there's sort of 2 ways that you could do that. One is we do have an LD preload shim, so that if you have a pod that you don't wish to change any of the code on, you could use that. And I expect this to be the minority of the cases, but there are people who have really high performance workloads that they care a lot about tuning. And if you have such a workload, so one of the things that everyone who does a high performance TCP stack eventually discovers is that the BSD socket API itself is a bottleneck. And so we do have a higher performance native API if you have a workload that you care so much about that you're willing to go in and alter the code, right? So for example, if you're doing a proxy like Envoy or HA proxy, that might be worth it to you. Probably not worth it for most workloads. Any questions so far? Cool. So just one layer down in terms of the stack. Effectively, this is just showing for the app containers in a pod, the LD preload shim case. We do have a concept of a namespace that is sort of directly analogous to the kernel's concept of the namespace. We can't use the kernel namespace because we're not running the networking through the kernel. Networking that's running over the VPP user space host stack never touches the kernel at all. And then this was for communication between pods, I had mentioned. Effectively, one of the things that's very nice here is that if you have 2 pods that are communicating and use the VPP host stack, VPP is only acting essentially to assist in the setup process. When you're actually passing bits between them, once the connection's established, they're basically going over a direct shared memory pipe. So you get insanely high performance talking between 2 pods that are sitting on the same server. Something like we've clocked the damn thing at like 100 gigabits per second between 2 containers on the same server. It's just ludicrously fast. So there is reality for this stuff in terms of integration. Contiv is doing integration right now with VPP. But one thing I did want to point out is it's done in layers. So literally anyone else could integrate with VPP in their Kubernetes CNI plugin. We do have a straight up Go library for VPP that anybody could use to build an agent. If you have an existing agent and just want to be able to drive VPP. If you're building an agent, we actually have an agent framework that could be used. So for example, you were talking about people wanting to run routers in containers for NFE. They could use that to build it. And then that sort of steps up to the Conti VPP agent. But again, anyone else, Flannel, Calico, any of the rest of those guys could also use VPP. We just happen to be doing it in Conti. And then
I had a question that kind of relates to this. It's more of I have a lot of questions actually, but I'll save them for another time. So is your vision for this that you're trying to get the other projects like Calico, Flannel, Weave to integrate this as their underlying switch or router? Or and the reason I ask that is that Contiv is one thing, but if more and more projects are doing this, that kind of changes a lot of things in Kubernetes in general. Like kube proxy would be one that wouldn't work in user space currently. So what is the kind of the vision for what you would like to see happen with it?
Yeah, I mean, so quite honestly, I'd like to see it adopted as broadly as possible because I think it solves problems in terms of performance and scalability and in terms of rate of innovation that I think would be good overall for the community. And I don't tend to be one who is going to let religion for one particular choice of CNI plugin or another sort of block forward progress. So I would love to see it integrated more broadly. I would actually, one of the conversations I want to have subsequently with you guys is, I know you currently support at least 2, maybe 3 modes in kube proxy in terms of having kube proxy manage how services are handled. I would love to talk about sort of what the rules of the road are for contributing additional integrations, because I'd love to get a mode where kube proxy would translate down to a user space VPP vSwitch to handle services if that's actually available and how the networking is being handled.
Yeah, I think that's a good conversation to have with this group.
Cool. Yep. And so like my closing slide is pretty straightforward. How can we help, right? The whole point of the conversation is to sort of see if there are problems that we could help you guys in solving. We've got a lot of fun tools, and the question is, do they fit? And is this something that would be useful for you?
Yeah, I mean, it sounds to me like this is a pretty awesome technology that a lot of Kubernetes users would like to take advantage of. Seems like you've gone pretty far already in terms of integrating, but like we identified, there's more to go.
You guys made it very, very easy. I mean, the modularity of designing Kubernetes networking makes it quite easy. The only point where it's sort of, you have to come and make sure that this piece falls into place right now is kube proxy. And so, I would love to talk about, getting some patches in there that would allow it to work with VPP, and or whether it makes sense to have, sort of an API mechanism analogous to what CNI does, so that you can have things that simply plug into kube proxy to provide that functionality.
I have a stupid question here about the words you're using there. On that first bullet, it talks about microservices, and you said that up front. But everywhere else in the middle, I didn't see any microservices, so I'm a little confused.
Yeah, so I mean, effectively, what ends up happening is your entire vSwitch can be thought of as a microservice. It runs in user space, it runs in a container. You stand it up and you run it in a container using Kubernetes. So you can actually then also lifecycle it and handle upgrades and things of that nature in a similar way. So right now, if I'm using a kernel-based mechanism for networking, if I want to go upgrade my networking stack, I've got to go and upgrade my kernel, which means upgrading my...
Sure. I mean, you said all that. So if the word used there was user space instead of microservice, I would understand it. For someone with a background in things like Istio, using the word microservice here is really confusing.
Oh, could you explain to me why? It would be very helpful for me to understand that.
Well, okay, right. So let's just talk with like the original proselytizers for microservices was Netflix, right? With their ecology of a bunch of microservices, right? And these are these big heavyweight things. They have a load balancer, they have a bunch of servers, and it's a higher level concept, I think. Right here, you're talking about a user-space switch. Well, not just switch, but processing.
Okay, no, that makes a lot of sense. I can tell you part of why I made that word choice, and you can tell me where it differs from your understanding, because your understanding of microservices is doubtlessly more sophisticated than mine. It happens to be the case when servicing Kubernetes that there are efficiency gains to handle your networking in a single microservice on a particular node. But there is nothing in VPP that requires that. And in fact, when you get into use cases like what was mentioned earlier, where you are running a bunch of virtual network functions in like a service provider use case, there are good reasons why you would want to have multiple network microservices in multiple pods. Does that make sense?
Sure, yeah, that's a particular use case. That's not the central idea here, right?
Okay, no, fair, totally fair.
Any other quick questions?
Yeah, I apologize. I told you I would.
So Ed, I'm sure there are lots and lots of questions in people's minds at the moment. Is there a way that they can follow up with you?
Sure. So two things that are probably going to be useful. So number one, I do hang out on the Slack channel. Let me actually make it clear on the Slack channel who I am. So feel free to hit me up on Slack. I'll drop my email there as well. And if somebody can point me to where to put the slides, I'm happy to put them wherever the local convention is. So I'd be delighted.
I don't know that we have a convention. Sharing Google Slides with the mailing list is one approach.
Okay. I know what the networking working group, the CNCF networking working group did is they just created a presentation slide in a presentation directory in their repo and asked me to drop them there. So, but I can do whatever makes sense to folks.
Yeah, let me have a think about that. I don't know if we have a good place for them at the moment. Most of the content is hosted on in Google Docs or Google Slides.
I can drop them up in Google Docs if that would be cool.
Yeah, I think initially mailing it to the list probably would suffice.
Yeah, so I think the right solution then is for me to stick it up in Google Docs, make sure it survived the transition, and send out the link to that to the mailing list.
Yep, that sounds good to me.
So one other thing to mention, there is actually a FIDO mini summit at KubeCon if folks want to dig in deeper.
Cool. Is that a scheduled session?
It's a scheduled. There's a full day mini summit on the 4th, Tuesday the 4th.
Right.
Okay.
It's actually sold out, so if you haven't gotten tickets yet, it's not available anymore.
Yeah, the way they've said that they're going to handle that is as long as the fire marshal doesn't stop us, we'll let people in the door. So.
Great. So we should have follow-up conversations about the kube proxy question and any other questions that people here have.
Cool. Mind if I stick the kube proxy on the agenda for next time?
Sure. Sounds good to me.
Cool. Awesome. Thank you.
Thank you. So moving on, Du had added using IPset for the IPVS kube proxy. Du, are you on the call?
Yes, I'm here.
You've got the floor.
Yes, currently we have received many issues in the GitHub reporting the IPVS kube proxy bug, mostly about the hacking issue and the cross-node visit node pod. And the root cause is that the IPVS proxy missed the SNet. And I feel like I have discussed in the Google mailing list about the IPset. And I already sent a PR and have received look good to me from Daniel. Daniel has reviewed the PR. So since the code freeze is coming, so I'm asking for code review and approval to solve the issues in IPVS kube proxy.
Yep. Do we know, is anybody on the call, do they feel that they're the one responsible for that PR? Is there a primary reviewer?
I'm not sure if time is high time. Are you there? Are you here?
Yeah, we could see if Tim has time. This is Bowie. I think there's a couple other owners of kube-proxy also on the owners file that you might want to ping.
Yeah.
Hi, Bowie. Can you take a look at this PR when you have a chance?
I'm actually not very familiar with kube-proxy. That's one of the things that you probably want someone else to look at. You can use the owners file and just try to find them on Slack.
I found the only the owner is the Cam, but I know he is very busy.
Do you need a approval, or do you just need someone to review it?
I need approval.
I see.
Since Daniel has reviewed and he gave me a look good to me.
Okay, I'm just tagged him on it. He should see it in his mailbox, and then I guess ping me on Slack if you are really having trouble.
Okay. Thank you, Bowie.
Oh, I was just muted that whole time. I was talking and nobody heard me. I was just saying the next thing on the agenda is SIG test review. And so I'll share my screen and we can go through that. Okay, can you guys see this all right? Can you guys hear me?
Yes. And it'll be easier to just look at my own copy.
Yeah, if people prefer that, that's okay. I thought this would help us keep on the same thing, but we can figure it out. So would people rather me not share this?
No, go ahead and share it.
Okay.
No harm.
All right. So I've got this up. I admit I'm only vaguely familiar with this dashboard, but from what I can tell, it looks like we have 5 in the 5 suites in the SIG Network GCE section that have failures. And it's probably worth us just going through those, understanding whether or not those are, or what the priority is, and if somebody is owning them.
Yeah. Hi, Casey. I have analyzed the failure case, and they are almost about this. For example, the DNS failures is that we are failed to get the proxy sub resource of the pod, and for the case about the service is that it requires SNet. It can be solved by my PR.
So you say these are fixed by the that same PR we were just talking about?
Yes. The case can be passed in my environment. My environment uses Flannel with the IP MaskQ, but the Kubernetes in the upstream CI has no MaskQ by default. So we need MaskQ.
You're talking about the masquerade support?
MaskQ, yeah.
Does I would have thought that the upstream tests are running KubeNet with its own masquerade. Is that not the case?
But it passed in my environment. And so I have dig this log. It said it wanted to visit this service and get the time out.
So I think we're saying that these test failures are currently with you, and that you think you've got a handle on them.
Yes.
With your current PR.
I can handle this, and there as a team in Huawei can take care of. We have 3 guys that can take care of this CI.
Okay, great. So I think the other 4 suites, yeah, so we have the kube proxy tests, and then we have the Calico and Flannel sets. So Bowie, are you the right person to talk about the kube proxy DS suites?
Actually, Zihong can comment
Hi,
on it.
Zihong. I did take a look at it. It basically fell on upgrade. It's not networking related. So the API server basically, like, I think it's panicking or something. It's stack tracing a lot of things that I already opened a bug for it. So I pinged the API machinery guys. And I think they are looking at it. I don't think there's much we can do here.
Great, sounds good to me. And that's the same, presumably, for the downgrade set?
Yep.
So the last 2 on this tab were the Calico and Flannel tests, which both seem to be failing during the like cluster turn-up stages. Christopher, are you still on the call? Maybe. I know.
I think I sent an email to someone in you at Tigera, and they said PR that was going to fix this.
Yeah, so I myself have not been too closely involved with the history of these tests. I know Chris Luciano and Eric on the Tigera team had been looking at these, and I think it was a kind of infrastructure problem with the cluster creation scripts. I'm not sure if that PR has been merged yet. It appears like it probably hasn't if they're still failing.
Yeah, I think it was waiting on that. That's what the message I got.
Okay. So I can make sure that that's getting progressed. I'll just take a note to do that. Cool. So I think if I understand this dashboard correctly, that's all of the SIG Network GC failing tests. We also have this set of GKE tests in which we've got looks like 1 failing test and a couple or a few flaky.
Yeah, let me.
Flaky.
This Bowie, I will dig into that one because it's on the GKE side.
Yeah. So with these suites, is this typically something that someone at Google will need to investigate?
I think so, if it's GKE environment related.
Yeah. Okay. So I think that's probably it. It sounds like we've got a handle, or somebody is at least investigating all of the kind of clearly failing tests. So the last thing on the agenda was just I wanted to raise schedule over the next month and a half or so, because I know holidays are coming up and we've got KubeCon. So I just wanted to get a feel for what we think we should set our schedule to be. So I've written down the next meetings. They would be November 30th, December 14th, December 28th, and January 11th. I'm assuming that at least the December 28th one is a no-go. KubeCon is December 7th, which falls between the next two. I know we've got an in-person meetup there. So are people okay with maintaining all those meetings except for the 28th, or what's people's availability like over that time frame?
I'm available.
Okay, so let's say we
It'd be hard to vote on a con call, but it looks okay.
Yeah, that's true. So I'll send out and suggest that we cancel the 28th meeting and keep the other ones on for now and see what feedback we get on the mailing list. And I think that is it. Any last topics or questions from people, or shall we call it 10 minutes early?
Do we want to try to iterate a little more on topics for the deep dive at KubeCon? I know we talked last week about doing that, and no one actually responded, except for when you tried to. You had to turn in something.
Yes. Yeah, it'd be great to go in with some topics. I know we've got ingress as the big one, and Bowie's circulated a document for topics on that. Are there any other major topics people think would be good for the in-person meetup?
Well, I wouldn't mind talking some more about the multiple networks. I'm still interested. I'm sorry, I just botched my schedule. I missed the last meeting that was on that topic.
Yeah, I think that's good. My guess is that when we get to this thing, there will be a couple dozen people that are not regular faces, and we'll have topics that they'll throw out, and we'll have to kind of prioritize those and bunch them up into interested parties. Just based off of the previous one. I think Mike, you were there as well.
Yes.
So, hi, yeah, this is Prateek. As I proposed a topic last time, I'm working on a tool to trace the IP tables in the Kube cluster so that it's easy to debug the networking between the pods. So I know there is very less time, otherwise I could have showed whatever progress I have and get a feedback and what other people think if it might be useful or not. There is still 5 minutes, maybe I can show it if it's fine and get some feedback so that I can work on it further.
If you think you can show it meaningfully in 5 minutes. Otherwise, I'd suggest booking some time in the next meeting, and we can give you a little bit more than 5 minutes.
Sure. Yeah, I think next meeting is fine. Then I'll have something more meaningful also. Thanks.
Yeah. Make sure I'll make sure that gets added to the next agenda.
Thanks.
So sounds like we've got multiple networks and ingress for the deep dive in person, and we'll gather other topics on site.
Yeah, that's the way it's going to have to work anyway.
Yeah. All right. So let's call it now, 5 minutes early, and I'll see you guys in 2 weeks. Thanks, everyone.
Thank you.
Thank you. Bye-bye.
Bye.